Okay, this is chapter 1. Hopefully you went over the calculator video. That will help you in this section quite a bit. So let's begin. Section 1 is graphing quadratic functions, and we're going to get them in a few different forms. But before we do that, we want to know the basic quadratic function, which is in the form of y equals ax squared plus bx plus c. A, b, and c, of course, are going to be numbers. And here are what the graphs look like. They are called parabolas, and they're U-shaped. Now on this U-shaped, there are a few different things that we can point out. If the graph is U-shaped and has a very low point, which is called the min, this is the vertex. So that vertex is the very lowest point of the graph. Now if you had a graph that went up, or I'm sorry, that goes down, then your vertex would be up here, so it'd be the highest point. So this is also a vertex. Okay, also on this graph you can tell what the axis of symmetry is, and that is just this imaginary line that goes through the center of the graph to where if we folded it, it would be a mirror image. Okay, a few things about parabolas that we can use as shortcuts. If we look at the letter A in the general function, if A is ... if that A is a positive number, then your graph is going to go up. So these two parts of the graph, those are going to shoot up. And then if it's negative, then it'll go down. So real quick, we can look at the function without graphing and tell whether the graph goes up or down. Now on the bottom here, if we were to compare every single graph that we did, compare it to the original y equals x squared, which is what I gave you in the first slide, you can tell also by looking at the A. So if your A, if you take the absolute value of that, meaning regardless if it's negative or positive, if it's less than 1, then the graph will be wider. And so here is your regular x squared. If it would be wider, of course, we all know what wider than that would be. It'd be something like that maybe. If the graph is narrower, meaning it's really skinny, then this A value, regardless if it's negative or positive, will be more than 1. So it'll be like a really tiny U. And of course, if it's the same exact width as this purple, then we know that the absolute value of A is 1, just like the A is 1 right here. Alright, so to find the vertex on your graph, there is a formula that you can use, and it's negative b over 2a. But this only gives the x coordinate. So here's your vertex. Remember, this is an x and y point. In order to find the x point, we can use this negative b over 2a. And then if we have a function, we can plug it back in, that value that we got, to find the y. That's also going to figure out what the axis of symmetry is going to be. So if you want to know what that is, remember this imaginary line that goes right through the center is x equals whatever that value is. In this case, it's 0, obviously. You can also figure that out from using negative b over 2a. So let's go ahead and try one. And we're going to use our graphing calculator a lot to sketch the rest of these graphs. So if we look at this equation, we have ax squared plus bx plus c. A is 2, b is negative 8, and c is 6. So if we use the equation negative b over 2a, b is also a negative 8, so we have to plug in negative 8. We'll have 2 negatives there. And a is 2. So if we simplify this, we have a positive 8 on top and a 4 on the bottom, which results in 8 divided by 4. Well, that's 2. Remember, that's only your x value. So we still need this y. But because the equation gives us y equals all of this, we can plug this 2 into each one of these x's and find out what it is. So we are going to do just that. Everywhere I see an x, I'm going to plug in a 2. And we use order of operations to figure this out. So 2 squared would be 4, and then times 2 would be 8. 8 times 2 is 16. And we have to use the left to right rule that you guys learned in Algebra 1 to figure this out. So 8 minus 16 is negative 8. And then plus the 6 will give us negative 2. Okay, so this value right here is the y, and that goes right in there. So over here in our graph, we go to 2, negative 2. And we just found the vertex and the axis of symmetry. Now, to make sure, because we all make mistakes in our calculators, we want to make sure that the graph is going to go in the right direction. So if you look at your A, that is a positive 2. So the graph is going to go up. So if you go to your calculator and you go to the y equals, and I'm doing that right now as well, okay, 2x squared, and I'm just plugging in this function right here into the calculator, minus 8x plus 6, and hit graph, you get the sketch and it does go up. So we're just going to sketch this with at least the vertex being accurate. And there it is. Okay, now sometimes in your book they will give you a different type of form. Instead of quadratic form, this is the vertex form. And this is cool because although it looks a lot differently, if we were to multiply all this out, we would get ax squared plus bx plus c. Now, this value right here, the h, and then the k, that is the vertex. So when this is in vertex form, they give you the vertex without having to do negative b over 2a. Now, there's one thing to remember though. Because this has to follow the same exact pattern, the x minus h, a little shortcut that I learned is just always take the opposite of what your h is here. So why don't you write that down in your notes if you're taking them. Take the opposite of h, k will be the same. So let's say that h was negative 2, you would say that h is really 2, positive 2. And this h is also your axis of symmetry. Alright, so let's go ahead and try one of these. If you look, we have the h right here and the k, just like we had in the last formula. Remember to take the opposite of h. So if h is positive 3, we're going to say h is negative 3. And then we're going to take the k and leave that the same. Now, this is your vertex value. So right away, negative 3, 4 is your vertex. So on your graph, you would go to negative 3 and go up to 4. And there is your vertex. Now, you're probably wondering, does the graph go up or down? Well, the same thing applies. Here is your A. So if your A is negative, the graph will go down. But you can sketch this by using your calculator. So if you go to your y equals, clear everything out. You want to make sure the negative half is in parentheses, so you'd write parenthesis, negative 1 divided by 2, parenthesis. Another parenthesis, x plus 3, parenthesis squared, and then plus 4. And when you push the graph, you'll see that sort of looks like this. Okay, the next form is intercept form, and this is going to tell you exactly where your intercept points are on your graph. So, this value right here, and that value, which is P and Q, are your intercepts. And because, again, they have to follow the x minus P, x minus Q, we're going to have the little shortcut rule that says take the opposite of what those are. So take the opposite value of P and Q. Okay? So these are the intercepts, and because they are intercepts, they will have a 0 as their y coordinate. So let's go ahead and try one of these. So here we have a P and a Q. Remember to take the opposite. So this would be -2, and this would be +4. Now we can't just throw these together and write an x and y coordinate. Remember, these are intercepts. So -2, 0 is an intercept, and 4, 0 is an intercept. So if we go over here on our graph, -2, 0 is right here, and 4, 0 is right there. Those are the intercepts of the graph. And what we want to do, because we do not have a vertex, meaning a point that's either down here or up here, because remember the graph is going to be in the middle of this somewhere, we could use our calculator to figure out what that is. So if you use your calculator, go to your y equals, and you're going to type in negative parenthesis x plus 2 parenthesis, another parenthesis x minus 4, end the parenthesis, and push graph. Okay, so you have the sketch right there, but I don't want you to estimate where this vertex is up here. So if you go to second graph and go to the table, we need to find out where the graph, all these points are going to be the same until it finally reaches a peak or a low point. And on my x and y chart, if I scroll to 1 for the x value, which is right here, I notice that that's 9. And on either side of this is the same value, 8.75. So 6, 7, 8, 9. So this 1, 9 has to be the vertex because that's the highest point on my x and y chart. Everything else looks like a mirror image on each side. So I'll just connect that now, draw the arrows, and I'm done. Okay, hopefully you understand some of the video. Like I said, you can repeat the video as many times as you want. Take notes. You can use them on the homework. And I will see you in class tomorrow.